Somewhere roughly 13 billion light-years away, the two objects are blazing with the light of 1 trillion suns, so bright that even at that unimaginable distance we can still see them clearly today. They date back to just 670 million years after the beginning of the universe, a sliver of cosmic time so early that if the entire history of everything were compressed into a single day, both of these objects lit up just over an hour after that day began. They're called quasars, and it's worth being precise about what that word actually means, because it isn't quite the same thing as an ordinary galaxy. A quasar is a brief, violently energetic phase in a young galaxy's life, occurring when enormous amounts of gas and matter spiral directly into the supermassive black hole sitting at its center. That process releases so much energy that the galaxy's core can outshine its entire surrounding galaxy by hundreds, sometimes thousands of times over, making quasars among the brightest single objects in the entire universe. On the 6th of July 2026, the European Space Agency's Euclid Space Telescope, launched in 2023 specifically to map the structure and history of the universe on an enormous scale, announced something remarkable: the discovery of 31 previously unknown ancient quasars, instantly more than doubling the total number of known quasars from this incredibly early period of cosmic history. Two of them stood out from the rest, designated EUCL J172902.756641 and 018.1 and EUCL J125308 7054.2.3. These two objects set a new distance record, surpassing the previous record that had stood since 2021. Their light reveals they were already shining brightly when the universe was only 670 million years old, roughly 5% of its current age. Here's why this genuinely challenges everything astronomers thought they understood. The supermassive black holes powering these two ancient quasars weigh billions of times the mass of our Sun. Standard models describing how black holes grow, gradually consuming surrounding gas and dust over long stretches of time, simply aren't fast enough to explain building something that massive in under 700 million years. It's a mystery we've circled before on this channel, from black holes that appear to have formed before their own host galaxies, to the strange population of little red dots scattered throughout Webb's earliest images. This discovery adds two more genuinely extreme data points to an already growing and deeply uncomfortable pattern. There's a second, quieter detail buried in this discovery that matters just as much to astronomers as the record itself. Every quasar found before Euclid's survey was, by necessity, an outlier, exceptionally bright, easy enough to spot across enormous cosmic distances, but never representative of what a typical early quasar actually looked like. Euclid's wide, methodical survey approach changed that. Among the 31 newly identified objects, researchers finally captured a broader, more ordinary population of early quasars alongside the record breakers, giving astronomers for the first time something closer to an actual census of the early universe's supermassive black holes, rather than just its most extreme exceptions. Antonio Lamarca, an ESA research fellow working on the Euclid mission, described the significance plainly. This discovery, he said, more than doubles at once the number of known quasars this ancient, and Euclid is expected to uncover many more as its survey continues, opening an increasingly detailed window onto some of the earliest chapters of cosmic history ever directly observed. What makes this discovery worth sitting with isn't just the record itself, impressive as it is. It's what it represents: direct light, traveling uninterrupted for over 13 billion years, carrying evidence of two colossal black holes already blazing with almost unimaginable power before the universe had even finished its first billion years of existence, a reminder of just how quickly and how violently structure managed to assemble itself in the earliest moments we can still observe. What do you think? As instruments like Euclid keep pushing further back, do you think we'll eventually find something even earlier still? Or are we approaching the true edge of what light can ever show us? Let me know in the comments. Subscribe, because next time we are covering 3I Atlas, an object from outside our solar system that is passing through our cosmic neighborhood right now.